0. This equation I'll get. Now we can see that this is a quadratic in x. Okay. So root for the x will be given as d plus minus under the root of d square minus 4 AC, मतलब df upon 2. Okay. So these are the this is formula to find out the root of x, and for the root to be real, for real root, discriminant should be positive. That is d square minus 4df should be greater than or equal to 0. So from here we get d should be greater than equal to 4f. So the minimum distance, matlab minimum value of d then
Ma'am,
will be equal
shouldn't
to
it be
4f.
negative D in the formula?
Again, repeat beta.
Ma'am, shouldn't it be negative D in the formula? Like
No
x
beta,
equal to
x is
negative.
equal to minus b. If it is ax square plus b bx plus c, then it is given as uh, minus b plus minus under the root of b square minus 4ac upon 2a. This is the formula, no? So like we
Yeah,
actually have b as minus here. So minus minus becomes plus there.
yes, ma'am. I forgot. Sorry, ma'am.
Mhm. Okay, so d is equal to 4f. So that means the minimum distance of between the object and its real image is 4f. So we can only get uh, the real image if the object and the screen are kept at a distance greater than 4f. Okay. And also we can understand from there that minimum distance will be when the object is kept at 2f, its image will also be formed at 2f. This will be the closest distance. This is the position where the object and its real image will be closest to each other. At any other location, the distance between the object and its real image will be more than 4f. Okay, is this point clear?
Could you repeat where it is the minimum?
When the object is at 2f and its image is also formed at 2f. So this is the case when, okay, this is the case for if u is at minus 2f, okay, yeah, to focal length, okay, at 2f. Its image is also formed at 2 times the focal length at, okay, it is minus 2f and that is plus 2f.
But
Okay.
it is a real image.
Of course, it is a real image. We have discussed it. Now, there is one position where if the object is kept at 2f, the image is also formed at 2f. At this position, the size of the object and image will be same and it will be inverted. Just refer to your table of object and image in case of convex.
Yes, ma'am.
Got it? Okay.
Yes,
So
ma'am.
this is the position for at which the object and the image will be closest to each other. At any other position, the separation between the object and the image will be more than 4f. Is this point clear? And also we get to obtain the real image of an object on the screen. The minimum distance between the object and the screen should be, or we can say the distance between the object and the screen should be more than 4f. Okay, then only we can get a scenario where by adjusting the position of the lens in between the object and the screen, we can obtain the real image of the object on that screen. Got it? Now, let's do it further. So, first point is clear to everyone? First result. Now, write down the roots of x. So, roots of x will be d plus under the root of d square minus 4df by 2 and x is equal to d minus under the root of d square minus 4df by 2. Okay. So let's say object distance u is this. If I take u as the first value, that is d plus under the root of d square minus 4df by 2, then what will be the image distance? Please do the calculation. D minus x. Find d minus x. That is image. What will the distance of the image from the lens? What I've taken? I've taken u is equal to x here. And this x is which is equal to d plus under the root of d square minus 4df by 2. So putting the value of x in the d minus x, find out what will be the value of v.
D minus root over D square minus 4DF.
Yeah. So you'll get this result, d minus under the root of d square minus 4df by 2. That means if one root is taken as the object distance, the other root is taken will be the image distance and vice versa. है ना? That means if I take d minus under the root of d square minus 4df by 2 as my object distance, then the image distance will come out to be d plus under the root of d square minus 4df by 2. So it gives that for the given separation d, which is more than 4f, for the object and its and the screen, we will get two positions of the lens. That means we'll get two positions at which if we keep the lens from the object, we will get its image on the screen. One distance is d plus under the root of d square minus 4df by 2. If I keep my lens at this much distance from the object, its image will be obtained on the screen, kept at a distance d, which is more than 4f. And also if I keep my lens at a distance of d minus under the root of d square minus 4df by 2 from the object, again we'll obtain its real image on the screen. So that means between the object and the screen, if the separation between the object and screen is d, which is greater than 4f, we will obtain two positions of the lens in between, for which we'll get a real image of the given object on the screen. Is this point clear to everyone?
Ma'am, could you repeat again?
Yeah, I'll write it again. I'll write it on the next page. So, matlab we are getting this result as that if separation between, if distance between object and screen is greater than 4f, ठीक है, where f is focal length. F means for focal length. ठीक है, in a convex lens, ठीक है, then there are two positions of lens between object and screen
And is it only convex lens because it's kept in a rarer medium?
yeah.
Yeah.
ठीक. That means when it is working as a converging lens. ठीक है.
So if a
तो
concave mirror is kept in such a
concave,
way that it is converging, then it would work for this also.
yeah, बेटा. ठीक. We are writing then there are two positions of the lens between object and the screen.
Ma'am, is it 4F into F minus FL?
No, beta. I'm represent saying that F here stands for focal length.
Okay, ma'am. Yes, ma'am.
Okay, this is just to show that F stands for focal length. F here is focal length. Okay. Two positions of the object between the object and the screen at which a sharp uh, image of the object is formed at screen. Okay, the distance between the object and the screen is greater than 4f. In a convex lens, then there are two positions of the lens between the object and the screen at which a sharp image of object is formed at the screen. Is this result clear to everyone?
Ma'am.
So that means we can displace our lens in between the object and the screen, and will obtain two positions of the lens for which it will form a real image of the object on the screen. Got it?
Ma'am, can you show the previous page?
Yeah, sure, Bacha.
Ma'am, over here you have represented x as d plus root under root d square, and then over there x is equal to d minus under root d square. So what is the difference between both of them?
Beta, we know that for the quadratic equation we get two roots,
Yes,
two
ma'am.
solutions, two results, and how we are getting two solutions. Like if you I think so by now you must have started solving, you have done the
Yes,
concept
ma'am.
of
Yes,
quadratic
ma'am.
equation. So you do have minus b plus minus under the root of b square minus 4ac by 2a. So here one root is minus b plus under the root of b square minus 4ac by 2a, and the other solution is minus b minus under the root of b square minus 4ac upon 2a. This is how the same thing I've written here.
Okay, ma'am.
They will get the two different values of x, one when we add and one when we subtract.
Okay, ma'am.
Ma'am, like the question we have done in beginning, ma'am, that in that question we can't use this UV method, ma'am.
No. That was because this method is valid when when we are obtaining the this real image of the object. And remember, this time also we are changing the position of the lens. We are saying we are shifting the position of the lens, but of course the according to the object distance, the object distance, that is the distance between of the object from the optical center. The object distance changes, then image distance is also changing. So in that question, we were keeping our lens fixed. And also my object was also fixed.
Yes, like D is less than 4F also.
Huh. No, that will not be. But yes, in this case, look, there is a situation again. You just understand. It is not that the for no, that the object and image are coinciding um, for the same object distance. Okay. It is not the
Okay.
case, right?
Ma'am, could you move to the next page?
Yeah. In that case, my lens was kept fixed. In the previous question, the lens was kept fixed. Lens was not shifted. So remember this point. And simultaneously for both the objects, image was coinciding. Here, when we shift my lens, then I'll get another image. And clearly the images won't be of the same size. They will be formed at the same position, okay, on the same screen, but the size or the magnification of the image formed will be different.
So basically, ma'am, the whole meaning is that we can have two positions. One of them is D plus under root d square minus 4df upon 2, and the other one is d minus under root d square minus 4df upon 2, right?
Yeah. Either I can say like this way, or I can understand this result in such a way that uh, if I interchange the position of the object and image, okay, if I interchange the position of the object and the screen, again I'll get the image of the object on the screen. This is what is happening. Either I shift the position of the lens, or I change, that means I make this as
Interchange
object,
their
yeah,
positions.
interchange their position. Still, I'll be getting the image of the object on the screen. So by interchanging the position of the object and image, we can obtain the image of the object on the screen.
Got
Okay.
it.
So like what we are discussing here, like displacement or UV method, you will be getting the some questions where you have to directly use these results. If the results and the concept is clear to you, you'll be directly using the result to find out your answers. Okay. So let's discuss further. Now, as I've told you that in this case, though we are obtaining the image on the screen, but the size of the image won't be same. Okay. So like in case one, if I say that this is the first case where my object is kept at a distance of object distance is u and image distance is v. In case 2, the things will get reversed. That means if my object distance is v, image distance will be taken as u, right? So if object distance is negative, image distance will be positive. So say in this case, the size of object size is, it won't change. Okay? Size of object, that means the size of object is say O, and size of image is I1. Here, object size remains the same, but image size will change. And say it is I2. Clear? So, if I find out magnification, which is the ratio of image height to object height, will be given as V, this is V upon U. So it will be V upon minus U here. And for the second case, this is magnification in first case. For the second case, magnification will be given as I2 upon O will be equal to minus of uh, U by V. Okay? Or don't get confused. This is negative is down only. Okay? Now, if we multiply the two, okay, I can say, or we can equate the two, because I1 upon O is actually equal to I2 upon O. Sorry, if like if you sorry, I'll again repeat. I1 upon O is equal to O upon O2, I2, right? Because this is the reciprocal. So can I say that I1 upon O is equal to O upon I2? Okay, from 1 and 2. Okay, because I1 upon O is equal to V by U, and I2 upon O is U by V. So they are reciprocals are equal. So we get a result that is O square is actually equal to I1 into I2. Okay, or we can say size of object is equal to under the root times of product of size of images. Okay.
Ma'am, could you explain what are these cases again?
Case 1, when we are keeping the object say at a distance x and the image is formed at d minus x. If I shift my lens, and say of distance between object and the lens becomes d minus x, the image will be formed at the distance of x from the optical center.
Yes, ma'am.
That these are the two cases. So first case, I'm taking object distance as u, then image distance is v. And then if I shift my lens such that now the object distance becomes v, the image distance will become u. This is what we discussed now, that object
Yes,
and
ma'am.
image distance can be interchanged. That's how I've taken two cases.
Yes, ma'am.
There's a relation between the size of the object and size of image formed in these two cases.
Ma'am, so this method can be used when we are moving the object and the image.
Yeah, there whatever scenario, but if the given case satisfies, you can directly use this result to find out the size of object or size of image, whatever is unknown and whatever is asked for you to find out.
This is only for when the object and the image replace each other.
Yeah. Then only you can use this result.
Yes.
Now, done, all of you written this point?
Yes.
Now say, keeping object and screen fixed. The position of object and the screen fixed. This is my object. And here is the screen. So I'm getting two positions of the lens in between. This is first position. And say then we shift this lens by a distance small d to get another position of the lens for which the image of the object is formed on the screen. Got it? Distance between the object and the screen is given by capital D. Then we can even find out the focal length of the lens using this method. So focal length of the lens can be given as F is equal to D square minus small d square upon 4D. You can remember this formula to find out focal length of the lens using UV method, where capital D is separation between the object and the screen, and small d is a the small distance through which if we shift the lens so that to obtain the image of the object on the screen again.
Ma'am, could you repeat what is small d again?
The distance through which we are shifting the lens, position of the lens. So by how much distance we are shifting the lens. I've told now that if we displace the lens, so the distance by which we are displacing the lens, so that
Yes, ma'am.
again the image of the object is formed on the screen. So you can directly remember all these results to use them in the questions. You will get some questions in your package also, or workbook. There are questions. Okay. So from there you can solve. Directly use. You have to directly apply these results to find out the answer. All these points are clear.
Yes, ma'am.
ठीक है. चलो. Lenses done. Let me give you one or two questions and then we'll move to power efficiency.
Mom, can we solve this if the small d is not given?
No, we need to know that by how much distance the lens is being shifted. Then
Okay,
only
so
we
we
can
can.
find out, no? Yeah.
So, ma'am, this cannot be given in the same question as the previous result. We cannot use the two
Yeah.
results together.
That means depending upon the scenario, like whatever the question, if this it is given that the distance of object and screen is this, and we shift our lens by this much distance,
Right.
then what is the focal length? You can directly use it.
Got
Ma'am, can we say that small d is difference of roots in the equation we get earlier?
Yeah, that is also because actually if you see, initially first time is the first object distance and the second time it is the second object distance. So of course you are saying correct, and this is how we'll be deriving this result also. This result comes from that thing only, that is the difference between the two roots, and then we solve to find out the focal length. Okay. So next is uh, let's do one question and then we'll move to power of the lenses. It's a combination question. Okay. Write down. Question is, yes, beta.
Can I the last for 1 minute, ma'am? I'll just take a screenshot. Thank you, ma'am.
A source of light is located at double focal length at double the focal length from a convex lens. Okay, of focal length 30 centimeter. At what distance from the lens should a plane mirror be placed so that the rays reflected from mirror are parallel after passing through the lens for second time. ठीक है, this is a question. draw ray diagram, try to understand what is being asked. And we are about to, our all the topics are about to end. I think so. I have to discuss power of the lenses, then combination of lens, and then one more topic is total internal reflection. With this, our syllabus for the current phase is done. And I've also started taking your doubts of section till section B we have discussed, na beta?
Yes, ma'am.
Other
Section
mirror
B and
part.
section A.
Okay, that means for mirror part only. So in the next class, major part of lenses also we have discussed. TIR is only left here. And today most probably I'll be completing power of lens also. So in the next class, I'll take doubts of assignment section ABC of whatever question you are having doubt. I'll be taking the doubts. Okay, so please be ready with all the questions. There might be a quiz also. Okay. So I'll first of all take your doubts and then there will be a quiz. In glorifier, so be ready with the, this appliance vagara, whatever is needed. I think so in whatever, gadget, your device, you are taking this class. So in that only you can take the test on glorifier. So be ready with all these things that there might be a test in next class.
Ma'am, I don't understand what this question is asking.
They're saying the source of light is located at double the focal length of the convex lens. That means the distance of the light source is 2f.
Minus 2f.
Yeah, minus 2f. So
Right.
you have to find out that that means this light ray will pass through the lens and then will fall on the plane mirror. And after reflection from plane mirror, it will again pass through the lens. They are saying that when it second time passes through the lens, it becomes parallel. Parallel,
So
matlab rays become
basically, it should pass through O.
parallel to principal axis. When they say it is parallel, that means parallel to principal axis.
Right. So basically, for the second time, that light should pass through the point O in the lens.
You have to think about it now. Will all the rays can pass through optical center? Can all the rays pass through optical center? So think of whatever can be done, you think, because this is based on the ray diagram, positioning, everything. So now I'll be giving you some questions which are actually which you can only solve if you are well aware of the ray diagrams. That means ray diagrams, position of the object and image, all these things, if it is clear in your mind, then only you can approach these questions. First, that's why I'm saying try to draw a figure where try to locate what is needed, what are the path of the rays, after from which point if the ray will pass, then how the path of the refracted ray will change. Go through all those points that what are the defined paths for the rays. Is anyone getting hint or should we discuss? Should we discuss, bacha?
1 minute, ma'am.
Ma'am, just 1 minute.
Well, I think now we should discuss, no?
Ma'am,
Yes, beta.
ma'am is the answer 45.
Yeah, 45 is correct. Very good. Sure. So it is given that this is my lens. An object is kept at a distance of 2x. So we know its inverted image will be formed a distance of 2f only. So let's take path of a ray from 2f. The ray will reach at this 2f. But then they are saying that we have to place a plane mirror on the other side of the lens so that when after reflection from the from this mirror, when the ray again passes through the lens, it will become parallel. The rays will become parallel. Okay. So we know that rays after passing through lens will become parallel only if the rays are passing through the focus of the lens. Have we discussed? Three paths. If the rays are parallel to principal axis, after refraction pass through focus, a ray passing through optical center go undeviated, and if rays passes through focus of the lens, then after refraction will get parallel to principal axis. That means if the ray passes through focus, okay, after refraction from the lens will get parallel to principal axis. Now for the ray to pass through focus, that means my virtual object will become 2f, will be positioned at 2f. So its image should be formed at f. Then only the ray will be, so that means the mirror should be placed in between f and 2f. If I place my mirror in between f and 2f, like this.
Then why not add 2f?
Because if I put it at 2f, the rays will go, it will take a path. But if I put it at f and 2f, then after refraction, this ray will pass through f, na? Reason? Because now this 2f will be the position of the virtual object. Rays are tending to reach 2f. So 2f becomes a virtual object. So its image will be formed exactly at the same distance in front of it. So if I'm keeping it in between focus and 2f, my object distance will become f by 2 and its image should also form a distance of f by 2 in front of the plane mirror. So that's why the path of the ray will be like this. And after passing through lens, it will become parallel to principal axis. This should be the path of the rays. Got it? Now it is given to us that focal length is 30. Okay. So this distance is 30 and distance between f and 2f will also be 30 and we have to keep it in midway. That means I'll keep it at a distance of 15. So what is the distance of plane mirror from the lens then? Distance of plane mirror from the lens becomes
45.
45. Okay. So distance is equals to 45 centimeters.
Ma'am, could you explain once again why we kept the barriers in between F and 2F?
Because we know that if the rays passes through focus of the lens, after refraction from the lens, the rays will get parallel to principal axis. Have we discussed? Have we learned this result? When the
Yes,
rays
ma'am.
are passing through the focus of the lens, then after refraction through the lens, the rays become parallel to principal axis. Now they are saying that after refraction from the plane mirror, and when the rays will pass through the lens, they will become parallel to each other. It can only happen if the rays are passing through focus. Now, the rays will pass through focus if you know if it is hitting on the plane mirror after reflection. It is possible only if the mirror is placed in between the position of the object and focus. The the center of the 2f and f we have to choose then. Okay. Is this point clear?
Yes, ma'am.
Ma'am, my internet connection was very weak. I could not hear what you said.
No, which point? Like complete question you are not getting.
No, like just the last part. Just like 1 second.
I'm saying that the mirror should be kept at a distance, yani midway between the object and the image position. We know that object position is 2f and image should be formed at f because we have to see that on principal axis which points are there. So object is 2f. So the image should be formed at f. That means rays after reflection from the plane mirror should pass through focus. So that means my
Right,
plane
ma'am.
mirror should be kept in between f and 2f.
Got it, ma'am.
Now write down power of the lens or optical device. Okay, so what is power? It is the ability of an optical instrument to deviate the path of rays passing through it. So whenever the rays are passing through it, the ability of this optical device to change or deviate the path of the rays is called its power. Okay. So if the rays are converged by the optical device, we'll say that its power is positive, and if it is diverged, the power will be negative. Okay. So if instrument converges, if the rays parallel to principal axis, okay, its power is positive, and if it diverges, its power is negative. Okay. So now the power, that means ability of the lens to converge or diverge, depends upon the focal length. Okay. More the value of focal length, less will be the ability to change the path or deviate the path. So that means power and focal length have inverse relation. For example, say I'm having two lenses with me. Okay. When parallel beam falls on one, say it converge over here, and for the second one, its focal length will be less because it's a thick lens, so it converge over here. So which lens was able to bend the path of the light rays more? The one having
Second one.
less focal length. Okay, this is f1, this is f2, where f1 is more than f2. So the one having lesser focal length was able to bend the path of light more. That means power and focal length have inverse relation. Okay. So for lenses, relation between power and focal length is power is equal to 1 upon focal length. Okay, where we measure power in diopter, okay, and focal length in meter. Okay, when we measure power in diopter and focal length in meter, then this is the relation. Otherwise, it will be if we are having this focal length in centimeter, then my relation becomes little different. So then power can also be given as 100 upon focal length if we are measuring it in centimeter. Okay. So if focal length is given in centimeter, then it will be 100 upon f. Power in diopter will be equal to 100 upon focal length. Okay. This is for lens. So we know that converging lens have focal length positive. So power will also be positive, and diverging lens has focal length negative, and hence power will be negative. Okay. Now let's come to mirror. For mirror, relation between power and focal length of the mirror is that power equals to negative of 1 upon focal length. Power in diopter is equal to negative of 1 upon focal length. It's very simple because we know that in mirrors, converging mirror has focal length negative because concave mirror is converging mirror which is having negative focal length, and convex mirror is a diverging mirror having positive focal length. So to take the result of power, to keep the result proper, that's why uh, the in the formula this changes are being done, that it is equal to minus upon 1 upon focal length. So it finally gives power for the concave as positive and convex as negative.
And for mirrors, concave is a converging mirror.
Yeah, beta. Because concave having focal length negative and convex diverging.
But ma'am, a convex lens is a converging lens, right?
Yeah. Convex lens is a converging lens when it is kept in air or a rarer medium. Okay. And concave lens is a diverging lens. Done?
Can you go to the previous slide for a second? Yes, ma'am.
Now write down combination of lenses. So if we have more than one lenses held side by side without any gap. Okay. Say first is having focal length f1, second is having focal length f2, third is f3. Then this focal length of this combination will be given as 1 upon f equivalent will be sum of focal lengths of individual lenses taken in accordance to their sign. Okay, so that means if I say f1 and f2, if I put the value, f1 and f2 will have the positive value if it is kept in a rarer medium, and f3, which is a uh, concave lens, will have a negative focal length. So while you are putting the values here, in accordance to their sign, we have to substitute the value to find out the this क्या बोलते हैं, this focal length of the combination. The points to be remembered while using this formula is that it is for thin lenses. This result is true for thin lenses. Next, for para-axial rays, this is true for para-axial rays. Then it is true if there is no gap between the lenses. ठीक है, when lenses are kept side by side. When lenses are kept side by side without gap. ठीक है. All these lenses are surrounded by the same medium. ठीक है. All lenses are surrounded by same medium. Okay. So when these things are true, but normally they will give you the situation like this only, but you should have this idea. So then you will substitute the values of the focal length in accordance to the sign in this relation to find out the equivalent focal length of the combination. Okay. Now we know that 1 upon focal length is power, so we can also find out the equivalent power of the combination. P equivalent will be equal to P1 plus P2 plus P3 and so on. So that means if we have to find out the power of this combination, we will directly add the powers of the individual um lenses in diopter and will substitute in the formula according to their sign, in accordance to their sign. Okay, to find out the answer. Is this point clear? Okay. So let me give you some questions. And here again, with these questions only, we'll practice for lens maker formula. We haven't done much questions on lens maker formula. Now, what was lens maker formula? Yes, can tell me what was lens maker formula?
1 by f is equals to 1 by v minus 1 by e.
No, this is lens formula. I'm saying lens maker formula.
Oh,
1 by f.
Equal mu minus 1 into 1 by r1 minus 1 by
Yeah,
r2.
mu minus 1 into 1 by r1 minus 1 by r2. Using this formula, we'll be solving some questions. I'm not giving you direct questions of these are the lenses. I'm giving you some questions where we'll practice lens maker formula and combination of lenses. So I'm giving you this question where there is a convex lens and a concave lens kept side by side. Okay. All the curved surfaces are having radius as 10 centimeter. Okay. Radius of all the curved surfaces is 10, kept in the same surrounding, that is air. Refractive index of first mirror lens is 1.5, and for the second lens medium the refractive index is 2. Okay. So we have to find out the power of this arrangement. So how can we do? We have to individually, first of all, find out using lens maker formula, find out focal length for first lens, then for the second lens, and then using the result of combination of lenses, we can find out the this overall focal length of the combination, and also you can find out power. So let's do power only, because power can we can directly whatever we are getting the 1 by f, that is actually power. So you can find out power of the combination.
Thirty diopter.
You're getting 30 diopter. Have you converted it centimeter into meter?
Yes, ma'am.
Ma'am, what do R1 and R2 stand for here?
R1 and R2 are the refractive index, sorry, the radius of curvature of first refracting surface and second refracting surface.
Yes.
Ma'am, is it negative 10 diopter?
Minus 10. So let's discuss it. For the first lens, if we see, this is R1 and say this is R2. For the first refracting surface, uh, the center will be here. That is along the direction of the incident ray. So I'll take it as plus 10 centimeter, or can be given as 0.1 meter, right? And for R2, it will be minus 0.1 meter. And then refractive index of the medium is 1.5 and second is F. So we can find out the focal length 1 by F equals to 1.5 minus 1 into 1 upon 0.1 minus 1 upon minus 0.1. So that means it gives us 0.5 into 10 plus 10. So it will be 0.5 into 20. So your answer is 10. Diopter I'm writing directly because 1 by F is equal to 2. And since we have converted the focal length, the distances in centimeters, so all this calculation is coming in 1 upon centimeter. Okay, yeah, sorry, 1 upon meter, yeah, meter inverse. That's why we can directly write it as diopter. This is for the first lens. For the second lens, in the same way, we can find out P2 as, for the P2, my R1 will be negative and R2 will be positive. I hope it is clear to everyone. For the concave lens, R1 will be minus 0.1 and R2 will be plus 0.1 and refractive index is 2. Putting the value here, so I get 1 upon F2 equals to 2 minus 1, 1 upon minus 0.1 minus 1 upon 0.1 will give you 1 into minus 20. So the answer is minus 20 diode. So equivalent power will be P1 plus P2, will put it with sign, so it will be 10 plus minus 20 will give you minus 10 diode. So this is my answer. So power of the combination is minus 10 diode. So with this, I've measured all the topics are done except total internal reflection. This is the one concept which is still to be done. All rest of the concepts are done. So your syllabus is more or less completed. I'll be taking your doubts on assignments, all the sections A, B, C in the next class. Okay, and be ready for the test also. Right? That means if you'll be completing all the 3 assignments, all the 3 sections of the assignment, you will be like more or less ready for the quiz also. Okay? Sure. Any doubt in today's lecture?
Ma'am, can you show the first page?
This is the first.
Ma'am, for the diagram which you have made, so for the virtual image, what is the direction of that thing? Like, is it like, you check?
This is virtual image. Object and this is virtual image.
So, ma'am, the direction of that refracted ray would be like towards the lens or away from the
These are the
lens?
2 different things, Veda. Which figure you are saying?
Ma'am, for which you have written virtual image, that one.
So that is like if my object is moving from focus to optical center, the image will be formed behind it. An image will move from minus infinity towards the, towards the optical center. That means with respect to object, image will always be behind the object and it will be enlarged as compared to the object.
So, ma'am, that virtual image represents the image formed for the
Object which is in between
Kept at.
focus and optical side.
Yes, ma'am. Understood, ma'am. Thank you, ma'am.
Ma'am, for the power of optical device, lenses, it will be positive only, ma'am. Positive 1 by f.
Yeah, for lenses it is positive 1 by f, and for mirror it is negative 1 by f.
Yes, ma'am.